Okay, going to record this video. Okay, also we can share on the YouTube also, my channel, YouTube channel. So we can again go through that these recorded lectures. So for your clarification concept. So the my YouTube channel is SV Nishanda. Okay, after end of the lecture, we have to go and visit. Okay, from today onwards, I'm going to upload the metallurgy and quality control video series. Okay, so the first video starts with the optical comparator. Okay, we see now how the principle is very simple. Okay, here there's a one light source. Okay, so whatever the beam of the light is incident on the plane mirror. Okay, now in that case, figure 1, the mirror is a plane. Okay, now what happened, that reflected beam also travel in the making angle theta. Okay, if we making a normal, okay, which make angle theta, and the reflected beam also make an angle theta. So in that case, the mirror is plane. Okay, what happen if a mirror is tilted some angle, okay, alpha. So what I observed, that if mirror is tilted by angle alpha, okay, the reflected beam travel through while reflecting into alpha. So that basic phenomena or the property of that reflecting mirror or the tilting mirror, I am going to apply in mechanical optical comparator or in optical comparator. Okay, so how, who's going to tilt the angle in the mechanism? Okay, that mirror is attached with the plunger. Okay, and that plunger is going to sense the roughness surfaces roughness up and down. So when the plunger is going to travel over the surfaces, the plunger movement takes place, so which tilt the mirror, and the magnification is occur on the calibrated scale. So on the same phenomena, all the optical comparators are works. This is a basic phenomena. Okay, so I'm going to apply now. Why it is called mechanical optical comparator? If you see the first half, the amplification occur because of the lever and pivot mechanism, and the remaining half, this phenomena or the magnification occurs because of that optical things, mean like the light source, condenser, and the mirror. So it is called as a mechanical optical. It is not a pure optical comparator. For the coming lectures or the coming slides, we discuss the pure optical comparator, Zeiss optical comparator. So everyone now knows why it is called as a mechanical optical comparator. The magnification is achieved with the help of, first half is mechanical and second is the optical. So it is called mechanical optical comparator. So how the magnification is calculated? The first magnification is L2 by L1. So where is the L2? Okay, from pivot to this plunger, okay, this is the L2, and the pivot and the main plunger, it is the L1. So if you're going to magnify, how to magnify? If you heading the distances, okay, according to that we can get the magnification by changing the length, pivot distance L2 L1, we heading, if you also magnify. Okay, and the optical magnification is achieved. Why it is called twice? I already discussed in principle. Okay, the angle is alpha, then the reflected beam is travel twice alpha. So the magnification twice, and the which depends on L4 by L3. So where is the L4? If we see from pivot to the calibrated scale, the distance is L4 here. Okay, and this plunger to this pivot distance is, this linear distance is L3. So that tilting is depends on the ratio of L4 by L3. Okay, so the overall amplification is twice L2 by L1 into L4 by L3. Now we see the next is the Zeiss, the pure optical comparator. Here that case, the one change is that we have to use the two mirrors here, M1 and M2. Okay, so M1 is, see, M1 is movable and M2 is fixed. So if we see here, that movable mirror is carries with along with the plunger. okay, whenever the workpiece surfaces roughnesses, okay, which carry with this plunger, okay, so when light source initially impinged or incident on the mirror M1, it again reflected, okay, suppose there's some angle is there, maybe alpha angle is there, so the reflected beam travel again in twice alpha, so first magnification occurs, again M2 is reflected again on over the M1 surfaces. Okay, so in that way, the multiple magnification is occur, and that whole magnification through via objective lens, I am going to concentrate on the graticule. Okay, now where is the what is the graticule? Okay, graticule nothing but is like a graph paper. The number of vertical and horizontal lines. Okay, over the graticule, okay, this is focused via objective lens, there's one dot like a dot, okay, and that scale or the graticule we're going to use the calibrated scale where the dot is stands, okay, so like that it is works. Okay, so change is only we have to use the two mirrors, okay, and the what is the light source which emitting the light source passing via the green filter, okay, what is the role of the green filter? The function of green filter is to see to allow only the green light and the filters the remaining all colors. This filter beam light pass through the condenser. Okay, now what is the role of condenser or function of the condenser here? Is to focus the light to the movable mirror M1 which carrying along with the plunger. See, there are two mirrors I already discussed, M1 and M2, where their mirror M1 is movable mirror which is operated by the plunger. Okay, so whatever may be the ups and down in the surface which tilt the plunger first, which moves the plunger in a vertical direction, and which again tilt the mirror M1. The plunger is the measuring tip. Okay, we know that we are going to check the surface roughness of the workpiece, and mirror M2 is fixed. Once the focus light from the condenser falls on the mirror M1 and they get reflected to the mirror M2 and again reflected to back to the mirror M1, as you can see that. Okay, so I already discussed, and the objective lens will collect the image and projects on the graticule. What is the graticule? The screen having vertical and horizontal lines as like a graph to create coordinate points. So we just go through the very fast in that animated videos of the Zeiss optical comparator. So just go through that videos. Just wait. Okay, now we go through the Zeiss optical comparators, so you can understood, okay, how it works. Okay, see, just go through that directly animated animation how they use it. Okay,
M2 is fixed. The light rays from the condenser lens fall on the mirror.
okay. See, yeah, the multiple magnification achieved, okay, with the help of that mirror M1 and M2. Okay, I already told you how it works. Okay, now see. Okay, see how the plunger moves the mirror in certain angles. Okay, so very simple self-explanatory figure already discussed. Okay, Okay, hope you understood the optical comparator here. Okay.